Okay, a question about number 12 from lesson 9. Which of the following lines is parallel to that plane, and do any of them lie on the plane? So, let's talk about what a plane, what that equation gives us in terms of information. So if this is my plane, I know that when I have it in scalar form, that means that I know my normal. So there's my normal, perpendicular to the plane. So in this case, the normal will equal 4, 1, negative 1. If a line is parallel and we have it in vector form, so for example, with A, what information do we have from A? From this equation here, we can get our direction vector, which is 1, negative 2, 2. So if we want to know if the line is parallel to this plane, so let's say we want to know if this is true, we have the direction vector, which is heading in that direction. That means that our direction vector and normal would need to be perpendicular. So to test for perpendicular, we need to know if the normal from the plane dot the direction vector equals 0. So taking the normal, 4, 1, negative 1, dot the direction vector, 1, negative 2, 2, calculating that, 4 minus 2 minus 2 equals 0. So we know, therefore, it is parallel. So we know that. We know that A is parallel. Is it on the plane? Well, if that line is on the plane, that means that its reference point would be on the plane. So we're asking ourselves, is 302, is that coordinate on the plane? So the way to check that is we're going to go back to the scalar equation of the plane. Plus y minus z minus 10 equals 0. And we're going to check. So we're going to check. My left side is 4x plus y minus z minus 10. My right side is equal to 0. So plugging in the coordinate 3 plus 0 minus 2 minus 10. Doing my calculation here, we would end up with 12 minus 2 minus 10, which is 0. Left side equals right side. So the line was parallel, and therefore the line is coincident with the plane, or it's on the plane. All right, so it is on the plane. So when you go through and do this for the other ones, because I'll let you leave those other ones for you to try on your own, B and C. First thing you do is you check to see if they are perpendicular, because if the normal and direction vector are perpendicular, that means you have a parallel line. Then you check to see, is my reference point from my line on the plane? So if you get down here and it's not equal to 0, if it was 5, you would know the line's parallel, but is not coincident. If you have any questions with the rest of them, let me know, and I'll see if I can help you out.